So, Assalamu alaikum wa rahmatullahi wa barakatuh. Okay, so welcome back, everyone. So, yeah, I'm continuing the previous video that was like, see, I think you all can see the screen. Yeah, so yeah, let me first, okay, do a little bit like intro. So, today is Tuesday, and mm, yeah, okay, so and 28th July, okay, this is like the part of the third video only, so that's why I've kept the third video. Okay, so where were we? So we were in the arrays code. Like we had, I had shown you like the linked list code in the last video. Okay, so in this video I will be showing, inshallah, like I will be showing you the stacks code that like I have prepared for the the DCA data structures algorithm lab, okay, in which like we have like I put all the functions and all the things in a compact code, okay. So I will be reviewing and also like making a revision of that code while explaining and trying to explain and also like learning in the meantime, okay. So let's head back to the code. And also it's like a theme and something like I'm forgetting the name of that uh, technique. Okay, Femans or something like I'm sorry if I mispronounce the names. Okay, it's something like Feman technique, which is like when you understand, when you've learned a concept and when you explain it. Okay, so yeah, you learn much better. So let's dive in and start. Okay, so yeah, stacks code. Okay, so just let me switch the window. Okay, so I think you all can see, yeah, and I think now it's visible. So let's start. Uh, in the starting, we have included all the libraries. Okay, all the files you can see the input and output stream and the string and the math and all the type also. And then the scope resolution, like not like using the scope namespace standard, and it's like whenever we are using the functions like cout and scene of from the namespace file, you can say, or the namespace folder, you can say like that, yeah, okay. And then hashtag define max size, that is wherever the max size it will be written, it will be considered as 100. So that's the thing. And then the first topic, you can say, that is stack using array, yeah. So first we are declaring a class array stack. Then in the private section we have put the array maximum size, that is array will be of size 100. And then a top, like, see, we are not using list, okay, like linked list. So we have put top because in array, yeah, we can refer to the index using index. We can refer to we can refer to the elements using index number, okay. So that's why just an integer data type top, okay. And then the public section where we have put the constructor array stack, where we are initializing, like you can say top, yeah, initializing top with -1, so that now it is now like it's, and the array is empty because it's -1. And then the bool, like a function bool, like it will return a bool. The function name is full, like we are checking if the stack like the yeah, the stack is full or not. So if like a return top is equals to max size -1, that means we'll be returning top is equals to max size -1. If top is equals to -1 and is equals to -1, max is 100, okay. Wait, max size is 100, 100 -1 is 99. So if top is equals to 99. Wait, I have to think about this. Mm, okay, yeah. So I got it. That is like, see, this top. This is like you can say the index, like the current element index. Okay, like the current element which is pushed into the stack. Okay, so it will be incremented one by one, and when the top will be equal to the max size. Okay, like the let's say 100. Okay, 100 minus 199. So when the top will become is like will be it will be equal to 99. That is the array is full, so it will return true. Okay, return top is equals to max size minus 1. So when the array will be full, it will return true. And so yeah, it will be passed in the like it will be returned from the function. And then bool is empty when it will be empty if the top is that is the initialized thing. Like if the top is already like minus 1 or like as we have constructed that if the top is minus 1, then it will return true, and it is obviously it will be empty. Okay, because see we have constructed here also like minus 1. The top is constructed as minus 1. That is the thing. And then the push function, so it is returning nothing. It is taking a value. If is full, now it will check with using this function if the stack is full. Okay, if is full, then see out stack overflow, and then yeah, return. Otherwise, what we are doing, we are uh, incrementing the top. Okay, so like if the top was now minus 1, then we are incrementing the top. Now the top will become 0, and that is the first index of the stack. And then we are initializing the value, and then we are like not initializing, we are assigning the value to that index. So the value will be stored at that index point. Okay, I hope you are understanding. So and then the in pop, like the popping function, deleting function. So it is returning an int. So yeah, it will return the key, the data that is going to be popped out. So that it will return. So again, checking if the array is empty. Why it's not checking if the array is full? Okay, yeah, if the array will be full, then obviously it will delete. And if the array is okay, yeah, empty is the problem. So that's why it's checking empty. If it's empty, if the stack is empty, then see out stack underflow, because we are trying to delete from the stack. Like we are trying to delete something from the stack, but with the stack is already empty. Okay, so that's the underflow condition, and it will return minus 1 for the same. Like when the when the stack is empty, it like we have put it minus 1. So yeah, minus 1 is like considered as it's empty. Otherwise, return. So when we do the popping in a stack, the first element, okay, not the first, like the element which is currently pushed into the stack, that is going to be deleted. That is the latest element that is pushed in the stack, that will be deleted. So that's why the what we are doing, we are just returning the array, uh, like arrays, like the stack's top value. Okay, like arrays top decrement, and decrementing the top. Like if the top was, let's say the stack had two elements. Okay, then what we are returning, the we are returning the second element. So okay, we are returning that element. We are returning the second element, but is pop delete like a deleting, because we are not deleting something, we are just like accessing the current element, the top element. But how, why are we not deleting? So we are just decrementing the top. So it's not a list, it's not a pointer. So when we decrement, like okay, okay, so see, I have got the understanding. Okay, see, here what we are doing is that we are first like pushing. Okay, so we have to push. What we are doing, we are first incrementing the top value because it is in the left side. Okay, I think yeah, I'm correct, right? Yeah. So first we are incrementing the top, then we are assigning the value. Okay, here we are incrementing the top, then we are assigning the value. Yeah. And here it's post increment. So what we are doing, we are returning the top. Like if say like there are two elements, no, only one elements. Okay, like array 0 is the first element, and that's only the element in that stack, let's say. Okay, so we are returning the top, that is array 0, the first and the only element of the stack, and then we are decrementing it. So again the array becomes, from 0 it becomes -1, so there is no element. Okay, so first here it's post increment, and here it's uh, what to say, post increment. Yeah, it's pre increment something. Okay, like that. And then a function like peak. Okay, so it is, peak is like seeing inside the stack what is in the top. Okay, so again it is returning the end. If the array is empty, return -1, again that condition. Otherwise, return the array's top. Okay, yeah, return just peak what is in the top of the stack. Then the display function, yeah, and then the display, if is empty, if the stack is empty, yeah, display print stack is empty. Otherwise, see out array stack top to bottom. So from the top we are starting to the bottom. From the top to bottom. Okay, so from for okay, then we'll be decrementing. Yeah, so we are decrementing the top. So this is the loop that we will use to traverse through the stack. So for int I is equals to top. So see, the top is in the starting. So what we are doing, we are not in, the top is like in the top. So what we will do, we will traverse from the top to the bottom. So that's the thing. Okay, and top will be like, from like, first will be the first, the stack will have the top like -1, then it will go, the first element will go to 0, then 1 2 3 4. Okay, and then like then the top will become something like, let's say, three elements, so the top will become 2 from 0 1 and 2. Okay, 2 is the top now. So what we will do, we will store the 2, int I is equals to top. Okay, so I will be storing the, what to say, 2, but the top is, yeah, 2. So I'll be storing 2, and then is 2 is 2 greater than is equals to 0. Yeah, and then we will start like in the, like we will go into the loop, like we will print the array to the top element, and then the decrement will happen, and then again it will go and go on from 2 to 1 until 0, like the last element. I is equals to 0, that is, yeah, it is true. Like, yeah, 0 is equals to 0, yeah, yeah, it's true. And then again that will be printed, and it will become -1, and then -1 is not greater than and also not equals to 0, and this will become false. Okay, so we will come out of the loop, and then next line is printed. And then, okay, so see, from here till here, the stack was implemented, stack was made using the array. Okay, and from here to here, from starting from here, we are implementing stack using a linked list. So just let me like show you just in a, in a visual, how, like, what is actually a stack. I know all of us know, but just let me, for my sake, let's just draw a small stack, some good color. What to say? Let's take the green. Let's say, okay, like this. This is the stack. Okay, you can imagine this also, like this structure also. Stack is a LIFO structure. LIFO, yeah. LIFO structure, last in, first out. LIFO, or no, no, sorry, it's a FIFO structure. First in, first out. No, no, it's a LIFO. No, it's a FIFO. So stack, the first element that goes to the comes out last. So last in, first out. No, first in, first out. No, last in, first out. Yeah, it's a LIFO structure. Last in, first out. So let's, okay, see, take the element here. Let's make the element like 1. So the first one came, then 2. Okay, let's see, 2 came, and then let's see, 3. Another 3. The third came, and then let's say 4. So which one was the last? Last was 4, and this is the top. Okay, so this is marked, this, the top index is this. Okay, so 4 came the last, and you can't make the elements come out from here. No, this is not stack. Okay, the elements will be inserted from here, and it will be popped out, that it will be taken out from here only. So the first in the first that will be that the first element that will go into the stack will be the first element to the, and it will be the first element to come out also. Okay, being popped also. So it becomes FIFO, first in, first out. No, sorry, again, I'm confused. Last in, first out. So it's a LIFO structure, LIFO. Or LIFO something, yeah. LIFO structure, last in, first out. Yeah, last in, first out. So, and yeah, same like this, only you can make the compartments here and here and here. This is a stack, okay. And okay, see this was array, and now we are going to make the same stack using a linked list. Okay, so in a linked list, it will be like, yeah, the same, but just using nodes as I've shown you in the earlier video. Okay, so the nodes will be here. Okay, and it will be like we will be inserting the nodes from here only, and we will be popping the nodes from here only. We can't insert it from this side. Okay, so it will be one side, and it's again the same LIFO structure, following the LIFO structure, last in, first out. Okay, yeah, you can imagine the stack as the the pile of plates where we put just like, okay, here plates, pile of plates, stack of plates. We say, okay, the last plate that came here will be the first plate to that will be that will go out from the stack. Okay, so that is the thing. I hope I was able to make you understand. Also, I was able to make myself understand. Yeah, I think I have understood it. Okay, so now let's move to the stack using the linked list, stack implementation using linked list. Okay, so here we didn't need a structure of the structure because there were no nodes, but here we will be needing, we will have a need to have a structure for a node. I shown you the bricks in the list using the linked list. Okay, so here we are making the stack node a structure. Again, it is having three, let no it is having two components. Okay, like the first is the data, the char data, where the, let's say, the data will go, and it will be stored as a character, and then the next pointer which will be pointing to a stack node only. So it is a pointer to a stack node only, that is next. It will be pointing to the next node as I have shown you, okay, in the visual. Okay, so that's it. And then we are using a constructor here, stack node, giving like a value will be passed in it. And then what we are doing, we are initializing the data with that value, and the next pointer will be initialized with the null ptr, null pointer. And then starting the class linked list stack, and then the private section, we are declaring a node, a top node, you can say a head also, like top node, yeah, pointer, no, like it's a pointer to a stack node structure. So yeah, we have declared this. And then the constructor for the class, when we will declare like when we will make an instance of the class, then the top node of that instance will be like, every instance will be pointed to null pointer. And then we are making a function, pool is empty. Again, we are checking. So like earlier we checked for the array, that's the same thing. So we are checking for like is empty bool. So this function will return a bool. Okay, and now how we are checking this? Return top node is equals to null pointer. So when the array will be empty, the top node will be pointing to null. Okay, so we are put in the condition like, if the top node will be equals to null, that means that may like this, then this will be evaluated as true, and this will be passed here. So is empty will become true. Okay, is empty will return true, yeah. And then the next function push. So it's easy than the array one, yeah. Void push function. We are putting the value that has to be pushed in the stack. We are making a new node because it's a list, so we have to make a new node, assign it memory, dynamic memory. Okay, yeah, new stack node. And then the value, we are putting the value here. And then what new, so when we want to push a node in the stack, so where we will be pushing the node in the starting. Okay, like, yeah, in the starting, like where the elements are going in. there we will be pushing. Okay, so yeah. So the new node's next pointer will be pointing to the new node's next pointer will be storing the top node. New node's next pointer will be storing the top node, and then the top node will become the new node. Okay, so let's just see it in the visual. Okay, just let me show you here, and so that I also can understand. Okay, on bro, what's thing? Okay, so yeah, let's. Okay, so this is the stack. One is already here, is here. So these are the nodes. Okay, so this is pointing to this, and this let's now top node is pointing to this. Yeah, oh yeah, like I forgot because like the early implementation was for the array, so I thought it was index. Okay, so now yeah, a little bit I got clear thing. So now we have made a new node tree, let's say with data 3, and it has a pointer which was like initialized with null. So yeah, so what we are doing, we are making the top node's next pointer point to 3. I think, yeah, right, that's the thing. Let me check what we are doing. We are declaring a new node. Okay, the new node's next pointer points to the top node. Okay, new node's next pointer is made to store the top node. Okay, wait. The top node's value is put in the new node's next. In the new node's next, the top is put where the top is pointing. How and why? Like how? The top is pointing to here, and then the new node's next is made to point to the top. Then, then top node is equals to new node. Then top node becomes this. Okay, so I think this is the case. See how we are inserting in a list. Okay, so just wait here. So I think this is this is the stack. Okay, and this is how the implementation is going. Okay, so this is one, let's say, the first node. So what actually it's like happening, like the top is now pointing here. Obviously top will be pointing to one. Now we have to insert two. Okay, let's say two we have to insert. So two, again it's pointing to null. So what we are doing, we are making 2.2 temporary, the top node, sorry. So now 2 comes here, 2 is pointing to 1, and the top is then incremented to this. Okay, so see what is happening. The point and the pointing is not going this side. Okay, so here it's wrong. Wait, yeah, no, right. Like I didn't show you the pointing. Okay, so it's pointing like this. Mm-hmm. So it's not like like the stack, and the linked list stack is not linked in this direction. In this direction. Okay, not in this direction, but in the opposite direction, like this. See here, this element will point to this element will be pointing to this, and this will be pointing to this, and this element, I think it will point to null. Okay, in the last, yeah. Now 3 came. Let's say 3 is the node. Come on, I have to make it fast. It is pointing to null. What we are doing? We are, wait, just let me correctly. It is pointing to null. What we are doing? We are making the new node's next pointer point to the temporary. I think that's the code. New node next, yeah, top node. Sorry, the top node. Let's see, I'm making a mistake temporary again. Yeah, it is pointing to the like new nodes next is made to point to the top node, and then the new nodes next is made to point to the top, and then what will be the next thing? And then the top will be increment, like the top will be updated, yeah, and then the top becomes 3. So 3 will be like here, it is pointing to 2, and then this will become the top. Okay, so yeah, like it is linking this way. So yeah, we have got it. Back to the code. So which function it was? Okay, so push. Yeah, I've shown you the push. New node becomes the new top. Okay, so yeah. Now the next pop function, it is returning the char, that is the value. So if the stack is empty, then return what it is returning, or slash zero. It's not returning null. If slash zero char really a null, okay, then I have to see, like I have to study it, that why it's returning slash zero. Okay, so this is a slash and this is a backslash. This is a slash and this is a back. Oh yeah, this is the backslash. Okay, so we have checked if the stack is empty or not, and then the next thing that we are doing is that we are making a temporary pointer that will be pointing to the same address of the top node. So yeah, see, we have made the temporary, okay, pointer point to the top node, like the way the top node pointer was pointing, and then we are getting the value that has to be popped, like, see, it is a stack. Okay, so the top node's value is only the value that is going to be popped. Like from the top only it's going to be inserted, and from the top only it's going to be popped out. That is deleted. So we are getting that data and putting it in the popped value variable. And then what we are doing, we are making the top node point to the next. So top top node next will be pointing to top node. Okay, so top nodes next will be pointing to the top node and then deleting the temporary and then returning the popped value. So just let head back to the visualization and see here. Can I show you here? Okay, let's try it here only. See, take an array, stack, this is the stack. So let's say here one and this is the two. Two is pointing to one and one is pointing to null. Okay. So it is two is pointing to one. Okay, so now the top node is pointing to two. Now we make a temporary pointer. Let's say temporary. It is also made to point to the top node. Then what we are doing, we are making top node point to the top node's next. So top node's next is one. Top node is pointing to this. Top node is removed. We got the value two in the first line only, and then we are just removing this temporary where the temporary is pointing. So this is deleted and only one is left. So see, we have popped out from the top. Now it's back to the thing. Okay, so see how we have popped the thing, and then the peak. Okay, so yeah, it's the same thing. If the like it is returning what is in the top. If the stack is empty, return the slash zero. Otherwise, return the top node's data. What is in the data of the top node, that is return that data only. So we have picked it, and then this is the what was this function called? See, the word isn't coming in my mind, but it's like a memory deallocator, you can say. Like it clears up the memory. Okay, the function that clears up the memory, and it's written with using the starting with the tilde, and yeah, it's used to clear up the memory. So in the last, it is used to clear up the memory that the linked list took, so that there is no memory overhead or like memory, what to say, memory leak. Yeah. So while the list is not empty, so yeah, while the stack is not empty, pop keep on popping, and when it is empty, just leave it. Okay, the loop will end. So now the third thing, stack applications. So yeah, these are the applications of the stack, like reverse string using custom stack. This is the function reverse string. It is returning a string. The reversed string is taking a string also, and it is taking a string by reference by using this alias. Okay, yeah, reference. of the string, and then we are declaring uh let's say an object or instance of a linked list stack, and then we are running a loop for char ch in the star. Okay, so the string that has been passed in the argument, the reference to the string that has been passed in the argument, so we are looking at each character, okay, of the string and storing it in the ch char variable, char data type variable. And then what we are doing, we are taking that each character from the string and pushing it into the into the s. The s is the linked list stack. Okay, oh my god, it's crazy pronunciation. So now we have got all the all the characters that was in the string in the linked list stack. Now what we will do, we are declaring a reversed variable of data type string, and with inverted commas, so that the I think the variable will be empty and no garbage value. That's the thing. And so that we can write directly into, we can append directly into the variable. Now running a loop while the stack is not, while the linked list stack, that is the S, is not empty, means until the stack is full, until it is not empty, append first pop the characters from the linked list stack and then append it into the reversed variable, the reversed string variable. Okay, and then the reversed. So just look at the visualization. Okay, again, let's say here is our stack. Okay, this is the S, you can say S, or to say S linked list stack. So here it is like, first take the string. Okay, let's say here it is written A B C. This was the string. So what we'll do, we'll first go through the string. Okay, while using the loop I showed you in the starting. So first the A will be taken into the stack, then B will be taken in, and then C will be taken in the stack. And then what we are doing, we are then popping these out one by one. So first, which is the first, so it is the LIFO structure, last in first out. So the C was the last to go in, so it will come the first, it will come first out. The first will be C, then B will come out. Okay, then at last A will come out. To see the string ABC came out as CBA, so it's it reversed. Okay, so that's the stack implementation. Now let's move to the next thing, and then we are returning the reversed variable where the reverse string is stored. And then is balance, again a function check if the, okay, so this is a function that checks if the parenthesis is balanced, like the brackets are balanced or not. Okay, so like the opening bracket and then the closing one, the same, like the bracket should be same. A parenthesis for a opening parenthesis should have a closing parenthesis, an opening curly brace should have a closing curly brace, and a opening square bracket should have a closing square bracket. So that's the thing. Okay. Sorry. So again, declaring a linked list stack, like linked list stack S. So I will let's call it the S. Okay. So again, for we are again passing the expression. Okay, passing the reference of the expression as an argument, and then we are as the same we are using the loop to extract each character by character from the expression. And what we are doing, we are then checking if the character is equals to the opening of any bracket, parentheses, curly, or the square brackets. If it is, then see in the middle we are using or. So if any one of this thing is like there in the character, then what we are doing, we are pushing it into the S dot push. Yes, so we are pushing it into the S, that is the linked list stack. Otherwise, if these are not there, okay. Otherwise, if these opening braces are not there, then else if ch is equals to, that is the character is equals to closing braces, okay, closing curly or closing parenthesis or closing square brackets, then what we are doing, we are checking the list, that if the list is empty, then return false. That is we are not balanced. Because see, if we found a closing bracket in the list, in the linked list stack, and there is no there and the list is empty, that means there is no opening braces. So like without an opening braces, how can a closing brace exist? Okay, like it is not balanced, so we are returning false. And if these are also not there, that is there in there is no opening brace in the character, there is like the character is not the closing brace, then we are checking for, then what, then okay, so then if the character is not opening brace or not the closing brace, and also like wait, I also got confused a little bit. So okay, and if it is not there, and then this condition is also not true, like if the linked list is not empty, if condition started from here and here, else if we started from here, it will be ending here. Okay, so else if if the curly brace is not there, like the opening brace is not the character and the closing also not not the character, then again the loop will run. Okay, and if the opening is found, then we will push it into the linked list stack. And if the what to say, if the let's say if the character is a closing brace, okay, and then the list is not empty, that is the list has the stack has elements in it, then what we will do, we are declaring a char variable, top char. Okay, so yeah, we have declared a top char variable that will be storing the top value of the list. So we have got the top value of the list. So now we can check the if the character is a closing brace and the top char. So see, if the character is a closing brace and the top char is the opening brace, that means uh, is balanced is false. But how? How? If the character is a closing brace, the top char is opening brace, then how it is false? Okay, let me think. Let's just use the visualization and what I'm saying, what I'm the code. Let's go to the code. So the thing, I just run the universe, the braces, and how the code you're doing. Each character in expression as first check if there is opening braces, then we are pushing it in the stack. Opening brace, the first is opening brace. Yeah, it here brace right after that, the loop will opening bracket. No, this will go into the second condition. If closing brace, then the condition is empty, return false. Tell us We know the stack to the top of on the top. We are checking is the you are now pointing which is the in which we were in like pressing this bracket is the CH closing brace is equals to this. Okay, that if H is brace not equals to this, the top chart equals to this is imbalance. Top chart, the curly brace. This is imbalance. Balance. Okay, so I think you are also understood that the closing brace is not okay. So the condition it is not okay. So that's why it is not closing curly braces. So yeah, equation is imbalance. Is not balanced. Is written false. Now let's head back to the code. Yeah, see the H current thing is a closing brace, okay, and the top chart is the opening brace top chart, and if the top chart is not is equals to in brace balance, just return the false. Okay, yeah, we have got it. Conditions that return the list is empty. If the stack is empty, then of course all the conditions and it went well. That means the balanced. Okay, also are quite like and good, 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 good question. The helper operator precedence. Okay, the helper function where we are using it to determine the precedence or the priority of the operators. Okay, return an end value. This is the function name district chart that is character as the operator. Operator is equals to power. Okay, so this if this is the operator return 3, that is it is the maximum precedence. Is multiplication or division return 2, is or subtraction then return 1, then minus 1. The what to say to calculate a uh, used I think in this version. Okay, three functions. I first we first discuss postfix or should we just like we just should I first like read the code? I think what to do. Okay, let's first like see what is a prefix and postfix expression. Okay, sorry, infix and postfix conversion. Like infix and postfix, what are they? Okay, so let's just it to see how humans calculate. Okay, yeah, thing in the red. Okay, so see, we calculate using this. Let's say a plus b to c. So what we humans do, we use brackets. Okay, to determine to like explicitly say that okay, this this a plus b is of more importance, so do it first. Okay, like precedence, this is given more precedence. Okay, so first do the addition and then multiply it by c. But what the computer, how they what to say, like how they evaluate the thing, that how do they determine the thing that we have to add first, they do by converting. Okay, so this is the infix, this is the fix. So the see the operators are infixed. Okay, so in infixed. Okay, in between the operands. So see this is infix, and what do the computers do? They understand outfix, and it's easy for them to evaluate. Sorry, outfix, or it's something else. Wait, let me see it. It's not out. It's prefix. Postfix. Sorry, postfix. Sorry for the writing. Okay, I'm writing in my laptop's mouse pad. Okay, so that's why trying my hard to maintain the writing. So postfix expression, how it's done? What they do? They first see, they first put the variables. Then they first write the variables. Okay, like A is there, A came, then B came, and because of the opening and the closing bracket, so we have to add these two first. Okay, so for adding these two first, this operator is then kept put here, so that like in the computer a will be there entered, then the b will be entered, and then they both will be added, and then at the last c, and then the operator, the last operator is there, that is multiplication. So what will the computer do? The first, like they will take a, then b, and then they will see this operator. Okay, then what they will do, they will add a plus b, and then the sum, like the sum of this a plus b will be taken here, and then they will see c. Okay, then they will input c, and then the multiplication operator will be like seen, and then it will be like multiplied the sum of this into the c. Okay, so I hope you have understood this. So that's the thing. Looking crazy. Okay, like yeah, I've done some. Okay, it was all from the link list and all. So now let's head back to where we okay. So I think I have made you understand a little bit the concepts. Okay, so yeah, here it is the function, a helper function only you can say, fix to prefix conversion. It is the like the engine of the main function here. This function where it went. Yeah, evaluate the postfix. Let's see what we are doing here. Again, this function will return a string. Okay, it will return a string. The function name is infix to postfix. It is taking a reference of the infixed expression like a plus b into a plus b bracket, like whole bracket a, bracket a plus b, then bracket close, then multiplication with c. It took the expression. It is then declaring a stack, because stack is like used. We can say yeah, it is like the we are using stack to do it. Okay, so that's the thing. What's next? We are making a postfix variable of type string, initializing it so that no garbage value, and we can append it later. See here, we are appending it, and there will be no problem. Just wait a minute. Hey, sorry, like a phone call came. So what we are doing? Where we yeah, thing list stack, declared a stack, then yeah, increment. Okay, then again running a loop, getting the again each character by character from the infix, the expression. Okay, if the is alnum, that is if the alphanumeric, if the character is alphanumeric, that is if the character is an operand. Okay, like a b or 1 2 3. If it is alphanumeric, then what we will do, it will be like in the condition, then what we are just pushing it into the stack, like as I show you. Okay, all the variables, like all the numbers will be pushed first into the, not in the stack, sorry, and directly into the output postfix variable. Then we are checking. so it's done. Otherwise, if it is not alphanumeric, then it will go into this condition. If the character is the opening braces, okay, that means high priority. What to say, high priority text are coming. Okay, so for that, if the character is an opening brace, then s dot push character, s dot push the character. Okay, so from the if there is an opening brace, then start pushing the character. Okay, start pushing it. Sorry, not start pushing it. Push that character into the stack. Or if the character is not an opening brace, otherwise if the character is a closing brace, then there's a loop. What is the loop? While s is not empty. So if the character is an closing brace, that is that the high priority expressions are inside the list. So what we are doing, we are using a loop to run through the whole list until the stack is not empty. The loop will go and s dot peak is not is equals to opening the brace or opening brace. So the loop will run until the stack is empty and also until the first element. No, sorry, until the stack is empty and until the opening brace is found. Until then, the loop will run, and then the all the things like the addition or the multiplication, all the thing that will be attended to the like appended to the postfix variable, as I showed you. Like I will be also showing you that. Okay, otherwise, okay, so we have got it. Okay, else if the condition was like an closing brace, otherwise if the character is not a closing brace, then if okay, so if the character is a closing brace, we have checked the while loop, and like let's say the while loop also ended, or let's say the while loop when the condition didn't match, then the while we didn't go into the while loop, then what will happen? If if the stack is not empty, s dot pop. If the stack is not empty, s dot pop. Wait, I can't understand this. If the stack is not empty, s dot pop. So this loop will run until the stack is not empty and until we find a, like let's say, an opening brace in a, yeah, an opening brace. So if you have found an opening brace, the loop will end, and then it will go into the if condition. If the stack is not empty, that is yeah, the stack is not empty, then we are just popping out. So what we will pop out? We will pop out the opening brace. Okay, so yeah, we have got it. And otherwise else, so if the, let's say, if the character wasn't closing brace, else what we are doing? So see, first we have encountered a character that is 1, 2, or A or B. We had this condition, we are just and then otherwise we like we hopped over opening brace, so this was the condition. Otherwise, if we have encountered a closing brace, this was all the things that was going to be happen. And if these all things didn't happen, that means we have encountered a operator, that is addition, subtraction, or multiplication, something like that. Okay, so while, so we are again running a loop. So see, we have passed all these conditions, that means it was obviously a operator. Otherwise else, operator encountered, yeah. So while the stack is not empty, so while the stack is not empty and precedence s dot peak. Okay, so the precedence of the top operator from the stack should be is greater than is equals to precedence of the top element of the stack is greater than is equals to precedence of the character. While okay, not empty, then precedence of the top thing of the stack, like the top of the stack is greater than is equals to precedence of the character. That means okay, the stack node was more higher. Then what you will be doing? So postfix add s dot pop. Okay. So in this loop, like if the precedence of the character, or let's say if the precedence of the element that was in the top of the stack is greater than or is equals to the precedence of the character or the precedence of the operator that we have found in this, like in this iteration, what we are doing, we are just incrementing the higher precedence operator into the postfix, that is the final variable, and then at the last just push the character. We are pushing the character into the stack. But how? One thing I can't understand is that, okay, the highest precedence is into the postfix first, and then the uh, less dot push character. Otherwise, like if the precedence of the character that we are currently on is greater than the precedence of the character that is in the list, in that time we will not go into the loop and we will just push the character into the stack. Why? Because because the stack had wait because the stack had because the precedence character had more okay. So see, in the last I understood that if the character's precedence is more than the one that is in the stack, then we are just pushing that precedence character into the stack. That is the thing. Okay, last thing. Okay, now let's visualize this in the concept. So let's head back there. It's up. Let's take sixth thing, not A. Six time, six operation. And of course, well, for well. What we need next? We need next. The next thing that we need is we need a stack, that is S. Okay, postfix variable we have made. Of course, the stack is this color. Okay, it will be same. Come on, different. Let's make a stack S. This is the stack S. Now what's the next? So again, we are starting in the loop, each character by character for the infix expression. So we are in the first character of the in the infix in the loop. Okay, is it alphanumeric? No, it's not alphanumeric. So we will not go into the condition. Is it an opening brace? Yeah, it's an opening brace. So what you have to do, you have to push that character into the stack, I think. Yeah, yeah, pushing that into the stack, or it became a square. We are pushing this curly brace into the stack. Then we are done. Yeah, we are like next character. We are into one. Is it an alphanumeric? Yeah. So what we have to do? Just add it into the postfix. Add this into the postfix. Okay, one is here, one came here. Okay, the next, that is addition. Okay, is it alphanumeric? No. Is it opening? No. Is it closing brace? No. Else operator. So we have got to the last condition where the operator was encountered. While and again we are opening a loop. Is the stack empty? No, stack is not empty. While the stack is not empty, while the stack is not empty, okay, true. And precedence s dot peak. the precedence of s dot peak, that is this, the precedence of this, that is the precedence of this is greater than, the precedence of this should be greater than is equals to precedence of the character, that is the plus. The precedence of the top thing, is it greater than or equals to precedence of the character? No, because see in the precedence, like in the function we had like -1 for nothing. Okay, you remember like in the end when it was not addition, multiplication or division or power, we return -1, so it's -1. Is -1 greater than is equals to plus? Plus was I think 1. Yeah, so plus is 1. So is -1 greater than is equals to 1? So no, it becomes false. So we will come out of the loop false. Then what we will do? We'll just push the character. What is the character? Plus is the character. So we are just pushing the plus here. And the next, is it alphanumeric 2? Yeah. 2 is alphanumeric. So just put it here to the writing. Just put the 2 here. So 2 came here. Again, we have encountered a closing bracket. Okay, so yeah, we will return to the, is alphanumeric? No. Is opening brace? No. Is closing? Yeah, it's a closing brace. While the stack is not empty, okay, the stack is not empty, s dot peak, okay, peak into the element, and while the top element is not an opening brace, okay, it's not an opening brace, the top element is not the opening brace, postfix add s dot pop. Okay, so keep on adding the top thing into the postfix. So plus was there, so we have just like we have put the plus there. Okay, so we will just remove this plus. Let's remove it because it has gone there. Again, we will go into the loop while the stack is not empty. Okay, the stack is not empty, and the top element, that is s dot peak, is not the opening brace. Okay, so now but it is an opening brace, so it will become false, and then we will come out of the loop, right? Okay, we have come out of the loop. Then again, there is a condition if the stack is not empty. Okay, the stack is not empty. S dot pop. So again we will pop this out, that is this bracket will be gone. Okay, so we don't need this bracket, as I have shown you that in the postfix we don't include the brackets. Okay, so this will be erased and the stack is now empty. So again we will go throughout again, like start the loop. Okay, yeah, again the loop will be starting. Okay, sorry, again the loop will, is it now showing? Okay, it's not showing. Come on, show it. Yeah, now it's showing. So yeah, so again the thing will start. Okay, like again the main loop will start. There was it one. So again it will go to this operator. Is it alphanumeric? No. Then what? Is it alpha? No. Is it opening brace? No. Is it closing brace? No. So it will go to the operator condition. Is while the stack is not empty. While the stack is not empty. The stack is empty. So we'll go. Will while the stack is not empty, but the stack is empty. So we'll just come out of the loop. We'll push the character into the stack. So this multiplication will be pushed here. Okay, so we have pushed the multiplication here, and the next thing again the loop will, like, we will just again iterate to the next character. Okay, 3 came. Is it alphanumeric? Yes. Just add it here into the postfix. Okay, then what? Then what? Then we will go to the next element, and the next element is nothing. So what it will happen? Like the no loop will not run to the next element. Yeah, right. Okay, it will not run to the next element. But then what will happen to the, what will happen? Okay, so see like the main loop will now cancel out. Okay, so we have now this 1 plus 2 plus 3. Now in the last there is like pop the remaining the operators that was in the list. So there is again in the last we have a loop. I will show you in the code only. While the list is not empty, while the stack is not empty, add into the postfix, like pop all the things from the stack and add into the postfix. So we'll pop this out. We will pop, okay, pop this multiplication out. Let's pack it, pop it from here. We will add this multiplication into here, the postfix. Now we are good to go. So we have found the postfix expression 1 2 plus 3 into. So what will happen? First 1 2 will be entered and then it will both will be added, and then the sum and then 3 will be here, and then the multiplication. Now sum and 3 will be like taken in, and then the multiplication will happen in between them. Okay, so we'll get the result. That is, the result will become 2 plus 1 will become 3. So this will also become 3. 3 into 3 will become 9. So this is the answer we will get. Okay, so that's the like thing that I that, that's the calculate that's how it's calculated using the postfix. Now let's head back to the code to see this pop the remaining operators from the stack. So this was the loop that will pop out all the thing from the stack, and then we will return the postfix variable where the postfix expression is stored. So this function will return the postfix expression. And now say this is the main function to say, yeah, evaluate the postfix expression. The main function to evaluate the postfix. So this has like three functions. Okay, the crazy evaluate postfix function. It returns an int. Okay, so it is actually a function that will evaluate. Okay, this just uh, what to say, this just evaluated the postfix. No, this just like this function is just like uh, a thing that makes the postfix expression from infix to yeah, and the name is also the infix to postfix, and this will evaluate the postfix expression and bring the answer 9, which I showed you. Okay, so it is also taking reference to the postfix expression, from where here you will get the postfix expression. So it is taking the reference from that. We are declaring an array stack. But wait, why an array stack? Using array stack for numerical calculations. Okay, so let's just use the array stack. Okay, so for numerical calculations, it's good to use array stacks because it's easy to access and no more pointers and memory overload and all. Okay, so that's the thing. So again, iterating character by character of the postfix expression. If is digit character, if is digit character. Like if the character is a digit, then what we are doing, we are pushing s dot push. We are pushing the character. We are pushing. We are pushing the value. Which value? Character minus 0. You see, any character, if we want to convert it to a digit, okay, we just subtract the character by the 0 character. Okay, convert the char into digit. So this is the hack, you can say, to convert the character into a digit. To see, like if 0 is, let's say, 64, let's say 34, 0 is 34. Okay, 0 character is 34, and 1 is like 1 is 35. Okay, 0 character is 34, 1 is 35. 34 minus 35. See that I'm taking an example. Okay, see, let's say 0 character has an integer value of, let's say, 20. Okay, it is actually like just what I'm telling, like just an example. Okay, let's say 0 character has a integer value of 29. Okay, and the 1 character has a value of 30. So what happens here? 30 minus 29. So 30 be like 30 is now taken as integer, and 29 is like integer because we have included the subtraction. So now the answer that will come will be in integer, like 30 minus 29, that is 1, and the character was also the 1. Okay, so that's the thing. I hope you understood it. So if is digit, if the digit is character, okay, then convert it into the, let's say, into its integer, digit integer. Otherwise, else, if the postfix doesn't, if the see, the postfix has a character or an operator. Okay, it will not have anything else. Otherwise, like a digit or an operator. Yeah. Else, we are declaring two variable of data type int value 2 and int value 1. So int value 2 will have the what it will store. It will store the top value of the stack. So the value 2, the val 2 variable will store the top thing of the stack. That is the first pop is operand 2. But how? Like we haven't, did we? Oh, yeah. So see, we have pushed the elements into the stack. So the last element will be put into the variable 2, and then the earlier element will be put into the variable 1. Like see, yeah, the LIFO structure last in first out. So the last element that will be in will be put into the variable 2, and the first element, like the first element which was put, will be put into the val1 variable. So again, switch case, switch ch. So we are like putting the ch, the character, into the condition. Like if we have found the, you see, if the character was digit, then this will happen. Otherwise, the character is an operator. So this will occur. Okay, declaring two variable and then popping out, and then putting the character into the switch statement. And then if the case is plus, add variable 1 and variable 2. If the case is minus, subtract variable minus 1 minus 2. And variable, this set is important because see, addition and multiplication will be good, but subtraction and division will be like wrong if it is not set as this. Variable 1 will of the past element and variable 2 of the current element. Okay, so that's the thing. The case 3, if the character is like this asterisk, then multiply. If the character is a slash, then divide. If the character is this, then it means power. Okay, so push, like we are pushing this. See, we are calculating, yeah, we are calculating the value 1 plus value 2, and we are pushing it into the stack only, and then we are breaking it. Okay, and then at the last we are popping the last element that was we that the last element that we pushed was the what was that only, like, or was the result only that we pushed the last. Okay, so that will be popped out. Okay, so now let's visualize it here. Okay, so this is the last thing also. Let's make it visualize. Let's visualize this here. Okay, okay, here only. It's taking so long. Okay, so what was this? Okay, so first let me see the code. So you evaluate the postfix expression. So same. Okay, let's keep the postfix expression as 1, 2. So see, we have got this expression from the earlier function, infix to postfix. So 1, 2, and plus was there, then 3 was there, and multiplication was there. Okay, then what we have? We have an array stack. So let's just make a stack, array stack. So it is an array stack. Remember we had the max element 100. Okay, so it will go upon 100. Okay. So now what we'll do, we'll go character by character of the postfix, and then we will check the conditions. So first, is it a digit? Is digit? Yeah, it's a digit. So we'll convert it into the see, it is now a character. Okay, now it's a character in the postfix variable, but we are now converting it into an integer by doing like uh, character 1, okay, minus character 0. Character 0 will all like will have a value 1, like will have a value 1 less than the character ones. Okay, so example like, yeah, again 30 minus 29. Okay, so the value will become 1. So this 1 will be like put into the, sorry, into the stack with 1, and then the 2 will be same, like it will be converted into its 2. Is it is it is digit? Yeah, it is a digit. And then this plus, the plus will be then the next character. Is it a digit? No, it's not a digit. Otherwise, else it will go into the else condition. Two variables will be allocated. Two variables will be allocated. Yeah, the variable two and the variable one, as I had showed you. So what the variable two was there and what the variable one was there. So here we will check. So variable two was s dot pop two. So this two will be okay. Sorry, the mouse pad. Variable two will be put here in the two. So variable two will like variable 2 had that s dot pop. So s dot pop will is the what is the first element, the top node, that is 2. It will be popped out, so 2 will be in the variable 2, and then the variable 1, now the see 2 is popped out. Okay, so let's make it, remove this 2. 2 is popped out. Now what is left? 1 is left. So again variable 1, now variable 1 had also the same thing, s dot pop. So now 1 will be popped out, so 1 will come here. Remember, 1 will come here in the variable 1. Variable 2 has 2, variable 1 has 1. Okay, so now 1 has been popped out. So the stack is now empty. Okay, so we have got the two variables. Now what the next thing was there? Let's check. So after that we have popped out, then we have the switch case statement, switch statement where the character was put in. So the what was the character? So this was the character. Remember, the plus was in the character. So in the switch case, the first case is only the addition. So what we will do? We will push the variable 1 plus variable 2. So this will be added. 2 plus 1, 3 will be got, and 3 will be pushed to the stack. Remember, we are pushing this here. So 3 is now there in the stack. Okay, then again we will go into the for loop in the, and then the next character of the postfix expression will be got. The 3 again, the 3 was there. So 3, is it a digit? Yeah, it is a digit. Is it? Then it will be converted into its respective integer, that is 3, and then multiplication will be there. Is it a digit? No, it's not a digit. Next character, that is it is not a digit. So what we will do, we'll again make a two variables. So you have got the two variables. Okay, let's delete these two, let's like erase this. Again we have declared, like, got the two variables, variable 1 and variable 2. Now what was variable 2? Variable 2 was popping the 3. So now 3 is gone to this. Wait, 3, this 3 will be going to this, and this 3. So wait, let me show you that way. So this 3 is now again going to the variable 2, and then this 3 will be again, this 3 is gone to 3, so this is popped out. Okay, let's say, and this 3 will be then popped out again by the second pop by and it will be stored in the variable 1. Now what happened? This was the character. Then it will go into the switch case, and then into the asterisk case, and into the asterisk case, and there the value where the variable 1 was multiplied with variable 2. So 3 will be multiplied with 3, so it will become 9. Okay, so then 9 will be again pushed to here. Okay, 9 is again pushed to the stack. So we have to, like, it was erase only. So 9 is now in the 9 is here in the stack now. Okay, and at the last, we are just popping and returning this. We are just popping. See, now the 9, see, now the 9, the result is in the top. As you can see, nothing is in the top other than 9. So 9 is then popped out and it is returned. So 9 is the answer. So this was the whole function. Okay, now let's head back the app. So see here, we have just popped out we have returned the top value of the stack, that was 9. Okay, then done. Okay, now the interactive main interface. So this is the main function where all the, like, we have composed all the functions and all the, like, all the implementations here. First we have put the choice and integer data type, that where we a choice variable of integer data type, and then array stack, an object or instance of the array stack, that is the array stack. And then we have put this do, like all the things to do. What it will do, like, it will print do while loop, we are using, it will print all these things. Okay, it will print, and then we are using a switch case, we are putting the choice here. and these are the choice: one, two, three, four, five. So case one, if the user entered one, all these things will happen, like we'll push into the areas tag, we will display it, and we will be all the things you can read also, and then break it. Otherwise, the case two, if the user enters two, then this will happen, like enter the string to reverse, okay, and all. Then the case three, like the bracket expression, like if the expression is balanced or not. Case 4, the infix to postfix conversion and all. And then the case 5, the single digit postfix expression, like evaluating the what to say, the postfix expression. And then the case 0 is like if the user entered 0, it is like they are canceling the program, okay. So just break it, okay. Yeah, see the break it, and if the user entered any crazy value, then just output invalid option. And okay, so do these do all the until and while the choice is not is equals to zero, and when the choice is zero, break the loop, return zero, and end the program, okay. So that's all the thing. So now let's see the stack engine and the parser. Okay, so let's enter the program. That was the linked list, okay. So now stack dot we have compiled the program. Let's see if there is no error. Okay, dot slash a. Okay, see now, yeah, the program is running the stack engine. Choice one, test area stack operations, push, pop, and peak. It is of question 19 of the practical DSA of my lab. Okay, so let's try the first one only. Okay, see, you have put the choice one, and then area stack top to bottom. So this was the area stack 30, 20, and 10. So 30 was at the top, 10, 20 was in the middle, and the 10 was in the bottom. Popped top value 30, current top peak. Okay, 20. We have popped this out to 20 left. Okay, area stack 20 and 20. Okay, then what to do? Reverse the string using stack. Okay, let's try the second. Enter the string. Let's. Uh, okay, it also like, yeah. So we have got the reverse string Mahra. Mahra. Okay, Arham. Yeah. So we have got the reversed. We have got the string reversed also. And then the next thing? Check the balanced parentheses. Okay, third. Enter parentheses. Okay. Okay. No. Let's say result unbalanced brackets detected. Okay. What's the next? Convert to postfix for enter the postfix expression. Okay. Try the same. Converted into the postfix 1, 2 plus 3 into, and then the last evaluate the postfix expression 5. Okay. And it, like, yeah. So, what happened? Evaluated result. Stack underflow. Stack underflow. Stack underflow 3. How? How? Wait. 5 evaluate the postfix expression. Okay. 1 plus 2 into 3. Okay, 1 plus 2 into 3. Why is that showing stack underflow? So we have to, okay, so that's the bug. We have to check it. Let's see if it is 0. Okay. 1 plus 2 into 3 into 3. So why was this 5? So the single time public available results post it post it flow. Digit post Let Postfix was asked uh, right. Check from my side also, like I didn't catch the error or underflow, and also like this prompt is asking for a postfix expression. So just we can copy this where the like just we can write this also one, two, three, and go. Okay, so now the result is there. So the problem was that it was prompting for a postfix expression, and we were giving a it infix operation, and that's why it was showing the error. And also there was a mistake from my side, like I should have handled that carefully without it showing an underflow. It should have printed like it should have like either handled the infix operation by converting it to that, or it should have just displayed that please display postfix expression or something like invalid prompt or something like. Okay, so that was all for the code. Okay, so now like the video has gone too long. Okay, like yeah, the video has gone too long. Like let me see the timing. Okay, like 1.5 hour. So that's all for today. Okay, like yeah, not for today. Like I will be recording the linked list also in in the afternoon or something. So that's for the stack. And Jazakallah khair for listening. Yeah, learn healthy, and enjoy. And yeah, Assalamu alaikum wa rahmatullahi wa barakatuh.